Um,
All right. So 1 and 2, easy peasy. Question 3, I thought was way easy as well. So in a pie chart, why are the slices or sectors different sizes? I would say because each slice represents a category, and the
Yeah.
area of the slice represents a portion. I feel like that's pretty
Yeah.
self-explanatory, right?
yep.
Okay. 4, how are bar charts and Pareto charts related? Pareto? I don't know how to say it.
Is it would be the last one?
Yeah. All I remember.
Yeah, because I know they're not.
Yeah, they're arranged differently.
Cool.
Yeah.
For 5, is the true portion or sample portion? It's the P.
Wouldn't it be the sample?
I think the P with the little arrow is the sample, and I think this one is the true.
Okay.
Okay. I don't know any different, so.
If we get it wrong, we can change it.
Yeah,
Exactly.
seriously.
6, what is N? Isn't it still the sample size?
Yeah.
Okay.
Yeah, I think so.
It would
This formula is like pretty straightforward. You don't have to do anything crazy. If P equals 1 over 4, what is the smallest N that satisfies the requirement?
Yeah, so I looked this up in the textbook, and the only point 2.1, how large is large enough? They have N needs to be greater than or less than 10. So I don't know if that would be our answer, like 10.
Let me see. What section did you find this in?
2.2.
2.2. Oh, okay, there we go.
Yeah. So I don't know.
Yeah, I don't know how we'd find this.
Yeah, because if P is 1/4, then that would be less than 1. What does it say?
We just like plug.
Yeah, because it doesn't give us any other info.
No, which is like doesn't make any sense.
Yeah, but it gives us the. Yeah, I don't know.
Interesting. Yeah, so let's just go with 10 for now, and then we can come and visit it later if need be.
Yeah. Okay.
Okay, so now we just need to find the mean of P. So we just plug this in, and we just put would we do the second, like the square root formula?
I think that one's standard deviation, so I think it would just be
the x over n.
0.4 divided by n, yeah.
Okay, do you have your calculator? Sorry, my phone's over there on the table.
Yeah, you're good.
So it'd be that formula. Oh, that makes sense. So because that P with the V over, it's the mean.
Yeah.
Come on, calculate.
Just
right. Do 0.4 divided by 24.
Okay. Hold on, because it's asking to round to the nearest 10th.
Oh, yeah.
Wait, I'm out, sorry. It's probably 0.
Yeah. Because did you get 0.01666?
Yeah.
Okay.
So we can just, it should be literally 0.
I guess we could just try 0.
Unless we times them.
Nope.
Oh.
I mean, I guess if it's wrong, we could just do the other formula, but I don't think it's that.
Yeah. Huh.
Now we need the standard deviation of it, so we do need to use that other formula now.
Yeah. So that's the one with P. Is that the one P parentheses 1 minus P?
Over n, and then square root that whole thing.
Okay.
Josh.
Let's try it.
So you're going to want to do 0.4 parentheses 1 minus 0.4 close parentheses divided by n, which is 24. And then you're going to want to square root that whole thing.
This whole thing?
Yeah.
Be 1 again, or 0 again.
There's no way.
Well, I got 0.1 when I did it on my calculator. I did square root.
Okay.
So I did parentheses, 0.4, and then parentheses 1 minus 0.4, close parentheses, divided by 24, close parentheses, close parentheses.
Got it, okay.
Oh, we just missed some parentheses.
Okay. Yeah, so I got 0.1.
Okay.
0.1, okay.
Now it's asking us to find, it's called like P hat or something like that, but we just need to find P.
Okay.
So would we just do the first formula, the x over n?
Yeah. I mean, because that's the formula I wrote down for it.
Yeah, me too. So 0.3 divided by 100.
What if it's two decimal places
again?
And it would just be 0?
Well, it gave us the probability applet, right?
Yeah, but I think we just plug in a z-score in that.
Yeah.
Not the mean for p. Huh.
So would we do 30 is 35x?
That's her sample, yeah.
Because 35 is what because x is like what you're looking for, and n is all the pieces. So n is 100.
Okay.
So it would be 35 divided by 100.
Which would be 0.35.
Okay. Yeah, that makes sense. So on the other one, does it give us more info?
Let's look now that we kind of figured that out.
Gives us n. And then,
which number?
Oh, yeah.
No, that one didn't give us any more info.
Didn't give us any,
so that one we'll just leave.
Okay.
What's the standard deviation? So now I'll throw it back into this formula right here.
Mm-hmm.
So that would be parentheses, 0.3, parentheses, 1 minus 0.3, close parentheses, divided by 100. Double close of parentheses. You need a double parentheses up here. What did you get, Jensen?
0.0446.
that's what I got, yep.
Sweet. What is the z-score? So now we pull the applet.
Yeah. But then we have to find... Don't we have to do... I don't know, because there was 2 different z-scores formulas. There's one for the sample portion, and then there's...
Mm-hmm.
Oh, no, it's the same. Because it's the p mean minus p divided by the standard deviation. Right?
Mm-hmm. Yeah.
Okay.
So the value minus the mean divided by standard deviation.
Mm-hmm. So our p is 0.046. And divided by 0.3.
Mm-hmm.
And then that divided by 0.046. So I got a negative. Oh, but then we plug it in.
Yeah.
To the applet.
And you got, what number did you get? Negative?
Negative 5.52.
Okay.
That is big. Because that doesn't work in the applet.
Or like shade a specific part?
Mm-hmm.
It said, in the normal probability map, shade the area to the right of its value.
Okay, let me try to calculate that again. So more than 35 is what she's looking for. So when we shade that.
Mm-hmm.
But the average is 0.3. Huh. Oh, wait. Oh, here we go. I plugged it in wrong. Okay, so I got 1.087.
Okay.
If we plug that into the applet, that works.
Yeah, that works.
Okay, and then would we shade just the left side or the right side?
I would assume the right.
Okay. So 0.139. What you guys got?
Yeah, hold on.
Okay.
Yeah, that's what I got.
Okay.
What was it?
0.139.
Okay. Okay, what's the probability that she gets at least 35 hits in her next 100 bats? So now that makes me think we did the first one wrong.
Because that 0.139 is for 13, right?
No, it's for 12. Oh, wait. Oh, wait. Yeah.
So we'd use 1.087 for the z-score, right?
What'd you say for the z-score?
1.087, isn't that the one? That's what we used, right?
We typed it in. Mm-hmm.
Okay. Sorry.
Oh, yeah.
We need to find the standard deviation for 14. It's the same formula.
Okay.
Yeah, I feel like this lesson, like, I can do formulas. It's when all you have those, like, 6 multiple choice answers. It's all look the same. It's what was so hard.
I know.
And 2 of them were, like, worded, like, literally exactly the same, except for, like, a couple of differences.
Yeah. Yeah, definitely. I know. I'm wondering how the review is going to go.
Yeah, seriously.
So for 14, I have 0.011.
Okay. Let me see.
Sorry, we're trying to
You're good.
half watching the election polls.
Oh, yeah, I was just doing that too.
What does Pennsylvania look like?
Barely, yeah.
Ugh, it is so freaking close.
Stressful.
I know. I do not know what's going to happen.
What states is it coming down to?
Coming down to Pennsylvania and Michigan.
Awesome.
Yep.
011 as well.
Perfect. 15, what z-score would we use? So now we plug it into this formula.
Okay, let's see.
Value minus mean minus. So do we need to like find the mean?
Yeah, because it just asked for the standard deviation.
So you just do the 0.52 divided by 2,000. That'll be the mean. And then the value, so it would be 2,000 minus whatever the mean is.
No, it would be our mean. Wait, it would be our mean minus. Oh, wait, what am I saying? Oh, it would be our mean, so our 0.011 minus 0.52.
Oh, okay.
Got it.
Yeah. And then divided by our. Oh, wait. Wait.
We have to get the mean.
What did we get for our mean?
So if we do 0.52 divided by 2,000,
Would be
0.0026.
Okay. And then that minus 0.52
We
divided by point.
We do the 0.011 minus.
Well,
Well, because that's our standard deviation, so I said it wrong.
Oh,
that's
yeah.
right.
Okay, now I'm looking at the formula. So
Totally
it's
my bad.
the mean minus p divided by standard deviation.
Yeah. So our mean is 0.00026.
Right. Minus 0.52.
And then divided by 0.011. Oh dear.
Oh dear.
That's a big number.
I think we actually.
Yeah, maybe we did something wrong.
Okay, because like the formula is throwing me off because it says value minus mean divided by standard deviation, but then like the letters it says p, hat, which is the mean, minus p, which is like the proportion.
Yeah.
So are we doing it backwards? Like, do we need to switch?
That's what I thought, but I don't.
Deviation of the mean. Let's see.
Okay, I'm looking at the example. Okay, so they found the mean, and they minused it by 0.05, which was p. Okay, so it is the mean minus p, which is 0.052, divided by the standard deviation.
Is what we did.
Okay, so
that's going to be huge.
Yeah.
It's like not even in the realm of possibility for a Z-score.
I'm so confused now on like the last two questions.
Yeah. Okay, well, the last question is saying that. Oh, wait. Well, it says what Z-score would you use?
I have no idea.
Yeah, that's so weird.
I feel like we have to, like, we're running this correctly.
Mm-hmm.
Did we calculate our standard deviation correctly? I mean, because that could throw it off if we calculated that incorrectly. Let's try to do that again, even though we both got it. But let's just see.
I checked it. Yeah, we're good.
All the parentheses are right.
Yep.
Mm-hmm.
I don't know what to do. I can't really do the next two.
Mm.
Shoot, kind of interesting. Z-score.
Yeah, that's really weird. Let's see.
So, okay, what z-score would you use? I'm just going to keep reading the book.
Oh, maybe we'll try this.
Oh, hey, it looks like the TA's on. Hi.
Hi.
Are we allowed to ask for help on this?
Yeah.
You see us struggling. Let's see.
Yeah, so for 14 is the question we're on. Well,
We're working on 15,
15 and 16, yeah.
but it's all kind of combined with that.
Yeah, because we plugged in, we have the formula for the z-score for 15, and we plugged in the numbers, and it came up with a wild, large number.
Like negative 47 something.
Yeah. We were trying to figure out what we did wrong. Is where we're at.
What, like, quiz thing are you guys looking at?
Lesson 16. The group meeting quiz.
I tried to calculate it different ways and still got the same z-score.
Oh, you did? Yeah, because it doesn't really give us like different formulas to use. Hmm.
Are we sure that's how we get our mean? With the 0.52 divided by 2,000?
I can double check.
I guess, yeah, we don't have any other numbers.
Yeah. Well.
Laura, what do you think about getting the mean? Is that how we typically do it? Is it just the p divided by the n?
Or it's x times
Or, yeah.
Well, the population mean is just P.
Okay.
So it would just be 0.52.
Well, 0.52. Let me try to calculate.
Well, okay. Well, we're asking for the sample, right?
Right, because that's what we need to get.
Okay, because there was a formula when we found the sample mean. It was the standard deviation divided by square root of n.
Okay.
You guys remember that formula?
Yeah.
Yeah.
So maybe, let's see, I'll try that. Okay, so I get like 0.00025. So maybe that's not right. Yeah, so that just freaks out the applet.
Mm-hmm.
Okay, so did you guys find the standard deviation yet? Sorry, I just got the quiz pulled up.
No, yeah, we do.
We got 0.011.
Okay. So then for the z-score, let me find, the p-hat would be 0.5 because it says the probability that they'll get less than 50% of the votes.
Okay.
We did what we did on the last question, where we missed that part.
5.
Divided by.
Okay, so let's see.
That should make everything work.
And then minus 0.52 divided by 0.01. 1.818.
Yep. Yeah.
Yeah.
Okay. And then we would just shade that right side again, right?
Uh-huh.
So 0.0.
345.
Yeah.
Okay.
Or would it just be 0.035?
Round to 3 decimal places.
Oh yeah. Sorry.
Oh. Yeah. Right around.
Now, do we need to look at the past questions and make sure because that 50% votes.
Well, we fixed it on the
fixed
one.
on the first one. Just 8 and 9 are the ones that we were concerned about.
Well, I think that the only number it gives you is P and N, so how do we find the mean then? Because I doubt the answer is truly 0.
Are you guys back at 8?
Yeah.
Yeah.
Okay. What is it?
So Laura, when we just have the N and the P to calculate the mean, because there isn't like a 50% of the votes or like X amount of batting swings or stuff like that. Does that make sense?
Mm-hmm.
So when we had calculated this originally, we got like 0.001 or something like that.
Yeah, and it says to round to the 10th place, so we just put 0.
And then number 9, again, we just got that point.
One.
And I just tried to do it again, and that's what I got.
Let's see. Put it in if you want.
With 0? We just don't
Yeah.
have other numbers or anything to even try.
Yeah, so that's why, I don't know. Then, yeah, it throws us off because it's asking for the 10th.
Mhm.
10th place, which just means it's 0.
Yeah. I don't even know if we're doing like the question correctly, but we only have so many numbers.
I'm finding
Yeah.
a p
I'm sorry, what question are you guys looking at again?
8.
Number 8.
Okay. What is the mean of p hat? So the mean of p hat is p.
That's it?
Yeah.
Oh, so we way overthought that.
We way overthought that. Okay.
So P equals. Oh,
0.4.
yeah.
Mhm.
And the other problem. Oh, never mind. Okay.
So that means our standard deviation would stay the same
Mhm.
at 0.1.
Yeah. What about number 7?
That's what I was about
That's
to
where I was,
say.
headed.
That's the only other one
So
we
1,
genuinely didn't know.
4.
7.
Okay, so
You were thinking 10.
the requirements are n times p has to be greater than or equal to 10, and n times p minus, or 1 minus p has to be greater than or equal to, or greater than 10.
Mm-hmm.
So you plug in p into the, like both of the, you plug that 1/4 in, so 0.25 in for p, and then solve for n and see which number, what numbers you get.
Oh.
Does that make sense?
Okay.
So you plug it into what formula?
The n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10.
Okay.
Oh, okay.
Okay, so let's see. Times. Wait. So n times p. Wait, so where do we get our. Oh, wait. Oh, never mind. So we would we do 10 divided by 0.25?
Yeah, for the first one.
Okay.
Well, 40.
Yeah.
And then
So that would equal.
this one.
And if we do 10, I want 5.
Let's see.
Wait, so are you guys just plugging it into the formula?
Right, so for the first one, n times p,
Uh-huh.
we had got 40, right? Or that's where we had 10 divided by 0.25.
Yeah, so that's our n.
And then the next one, we do n parenthesis 1 minus p close parentheses, which would be
Uh-huh.
5.
Okay, let's see. It's important to check both conditions. If one of them is not satisfied, cannot conclude that p hat follows a normal distribution. Observe these two conditions. P is close to 1, then P isn't close to normal. Okay, so then it's asking for the smallest, right?
Yeah.
So 7.
So what? 0.5?
I would say so.
I would think.
Okay, well, I think that's all the ones we had questions on, so I can turn it in and see if we're done.
Okay.
So we missed 15 and 7.
Okay. And 15. Okay. So do you guys want to do
Want to just keep working on 7?
That's what
7? Yeah. Okay, let's see. Let's crack this out.
So for number 7, it says what is the smallest n that satisfies the requirement.
So
So it's actually going to be the larger of the two n's that you get. Because if you plug the smaller one into the other equation, it won't work. It'll be too small.
Yeah, because it's less than.
That makes sense.
Okay, so it would be our 40.
Mm-hmm.
Okay.
And then 15 was that z-score.
Yeah.
Now we have the 50% of the vote.
Yeah.
You'd be able to find z-score easily.
Yeah. Let's see. So Sydney, you had 1.818 in there?
Let me double check.
Okay.
Yeah.
Okay. Okay, so let's try that again. Okay, so 0.52 minus 0.5. 1. Okay, so got the same answer.
So I guess I'm confused how to do it then if we didn't get it right the first time.
Yeah. Let's see.
So
Because we just did the 0.52 minus 0.5 and then divided by our 0.011,
yeah.
right?
Yeah.
So you actually do the 0.5 first, because you do p hat minus p.
Okay.
And then you have to like retype in the equation for standard deviation, or it'll give you or the wrong answer because of rounding.
Oh.
That so you have to like completely like type it all out again in the calculator in order to get it.
So I just did that, and it gives us negative 1.79.
Yeah, that's the right answer.
Okay.
Cool.
Negative 1.79.
I need to write that down so I don't forget.
1.79 7, and 9. So I guess for future assignments, the thing that we got to remember is just to input again the standard deviation formula.
Mm-hmm.
Around that number.
Sweet.
Okay, so I'll turn it in and see where we're at then.
We should have gotten 7,
Hopefully
right?
we're
Okay. Yeah.
Right.
11. I must have typoed. Sorry, I made a typo.
11 and 0.046. You missed a 0.
I missed a 0.
Okay, well, we got them all right
Hey, Jensen,
then.
yeah, you're looking good.
Okay. Now let me.
So we're done. That was
Okay.
So, Laura, did you need to do anything specific with us? Or did
No.
you just want to poke your head in?
Yeah, just come to make sure you guys all are doing good.
Well, I'm glad you called because
We wouldn't have figured it
so
out.
much easier for us.
Definitely.
sweet. Well, we're all,
All
set
right.
then.
Okay, we'll see you, Jensen, then on Tuesday.
Thanks for coming to the meeting.
Thanks a ton. See you guys.
Bye.
Bye.